Dear friends, today we will be talking about the LIVFAST Sinewave Inverter, which is FCS1125. Let's have a look at the back side of the inverter. Here you can see there are two main leads. One is black, the other one is red. These are actually the main leads which are connected to the battery. The red one is connected to the positive terminal of the battery, and the black one is connected to the negative terminal of the battery. We can also see there is a power connector. It is the main input to 24 volts from the mains. We have a reset switch, and we have the inverter output, which is a sine wave, which is approximated to around 220 volts, 50 hertz. We also have an adjustment panel. We can see there are three switches. On the leftmost side is the bottom side is the battery charge mode, and it is set to the middle section, that is M. That is because we are going to use a battery which is having a capacity around 150 ampere hour to 160 ampere hour. Usually the battery that we are going to use is 160 ampere hour. So we are keeping the settings in the medium, and you can change the settings as per your battery. Now there is again a selector switch which is above, which is regulated and unregulated. We will select that to the unregulated section. The bottom side is the battery type, and since we are using a tubular battery, we will set that particular section to TU, and you can set as per your battery requirement. Now, if you want to use computers and others, or you want to use it in the UPS mode, then you have to set the switch, the top switch, to the regulator section, that is REG. This is as per the manual of LIVFAST FCS1125. Now, this is the exhaust fan. You must always keep clear, so that whenever the system is heated up, the exhaust fan works properly. Now, this is the tubular battery, that is MXTT 1963, which is a 160 ampere hour battery. We can see the initial box pack. Well, the battery has already been removed. I'm just showing you the box pack. Here we can see that the battery that was unpacked has been placed, and we can see the terminals here. We just carefully see the terminals. One of the terminal will be written as positive. There will be an indicator there, and another one will be the negative one. So this is the battery that we are seeing. It has been kept over a wooden piece. It keeps the battery well, and after placing the battery, you always need to check the indicators which actually are in front of it. Those indicators are actually show whether the distilled water inside it is properly filled or not. Now you place the inverter in front of it. It can be very close to it, but we have to remember that the exhaust fan must have a clear space so that the cooling can be efficient. Now we have to connect the battery leads to the battery. The first battery lead that you need to connect is the positive one. Here we can see the red wire. Remove the nut carefully, and not to lose it. Now place it inside the terminal. There's already a hole inbuilt into the terminal.
It is always preferred to apply the petroleum jelly that is provided with the battery. Now carefully put the nut onto the bolt. Always remember there to put the washer and the clip washer, which keeps the nut very tight. Now place the nut above it. Make sure you don't turn it in a wrong manner, otherwise the edges may get damaged, the threads may also get damaged. Now after tightening it, you need to have a spanner. I have used the spanner which is the size of 13 and 14. The 14 usually gets connected, is used to tighten up the bolt, and the 13 the nut. You can just see it is shown here. Now the next part is we have to connect the negative terminal. Now please ensure that you connect the negative terminal switching off your inverter. Make sure the inverter is off, else you will see a spark like this. You may also see a spark even if the inverter switch is off. That is because the internal circuitry gets powered on. Here you can see it is on and it is presently running on the battery mode. The power is on. Now you have to tighten up the nut again. Use the spanner and obviously the petroleum jelly provided with the battery. You see here we have the switch. If you switch it off, you see only the economy mode is shown because we have kept the back switch in the adjustment panel in the unregulated section. This actually gives a better performance. Now again tighten up that, and now your inverter is ready to function. But before that we have to understand the wiring diagram and how it is actually carried out. This is the schematic diagram of inverter. Now you can see on the left hand side we have the energy meter that has been connected with the main lines which has been supplied by the electric company, and on the right hand side of the meter you can see there are two wires. One is the black one, another one is the red one. It is the live wire and it is actually connected to the MCB box via a fuse. Now this has to be the input of the inverter. So the input line that we have with the inverter is actually it is actually directly connected to the mains. It senses the AC and it connects the input line with the rest of the electrical appliances. Switchboard which is meant for the inverter gets connected to the input terminal of the inverter, and the live wire gets into the inverter as well as the neutral wire. So the output of the inverter, we can only connect the live wire through a MCB to those appliances which will be working when there is an AC failure or the input line failure or the electricity failure. So on the right hand side you can see a pink wire has been connected only. This is the output of the inverter which is going through an MCB to only those appliances which need backup, or they will be working during a current failure or during the load shedded conditions. The maximum amount of load that you can connect with the inverter is specified in the manual, the user manual, and you need to make a guess or estimation that how many appliances you can give a backup during a power failure. So in this inverter that we are discussing right now is FCS1125, which is actually having an exact output of 900 VA. So In order to calculate the maximum load that you can connect, you need to know the approximate wattage of the appliances that are being connected with the inverter. Now, it is always recommended that all the appliances that will be backed up by the inverter should be less than the specified VA of the inverter. Here the VA of the inverter is 900, so it is always recommended that the appliances that are going to run together should be less than 900 and should not cross 900 VA. It is also recommended that we do not use or do not connect any loads which are inductive, that is motor or AC, that is air conditioner, or loads like electric iron, or you have the micro oven, OTG. These are the equipments, or the fridge also, induction cooktops. These are the appliances which are having a lot of high wattage. So they will be consuming a lot of current, and it is not recommended to connect to your inverter. There are inverters which are specifically designed to run or give backups to this heavy loads. So whenever you purchase any inverter, it is recommended that you check the inverter specification before you purchase it. So to quickly sum up this schematic diagram, we can see that the input line is connected with the MCB box, which senses the input AC line, and when it is available, it will be directly connected through a relay inside the which is inside the inverter to the appliances which are connected through the output of the UPS. Now, in case of a power failure, the internal circuit, which is powered by the 12-volt battery, will have a DC to AC converter, which then will generate 220 volts at its output, which is because of the modern circuitry and microcontrolled inverters, we have a sine wave output which will drive the appliances which are connected with the UPS or the inverter. So when again the power is available at the input, it will sense it, and again it will switch back using the relay, and the input currents will be directly connected to the appliances through the inverter. Well, now here we can see we have a switch box for the inverter, and this is the energy meter. From there, it is the lines are connected via a fuse to the. We can see the switch box here on the right hand side. It is having a lever which can be used to break down the circuit, and after that we have a isolator. It actually cuts neutral as well as the live wire, and then it goes to the switch box meant for the inverter as shown here. Now let us first switch it off, remove the plug top, and then take the input wire of the inverter and push it into the socket meant for the inverter. The main lines that will be connected to the appliances will be connected at the back of the inverter. Here we can see we have the white plug top, which will now connect that at the back of the inverter. So we are taking the white top plug top and we'll push that at the back of the inverter. Now these are the connections which will drive only those appliances which are meant to be driven during the power failure. That means we will be bypassing the heavy loads like AC and other equipments which cannot be driven by this inverter. So this makes the entire connection. As you can see, there is a black and a blue wire which is meant for the AC, and it is not connecting or not driven via the inverter. It has been bypassed, directly connected from the switch box to the AC MCV that you can see on the left hand side, and then it goes to the that is the air conditioning unit. Let us push back the inverter and switch it on. When we switch it on, we'll be able to see a power LED indicating that it has been switched on, and just beside that you have the economy mode, and on the left hand side you can see there are two green lights indicating one AC is available and the other one it is charging. Now let's switch off the switch which is connecting to the inverter. I can see on the left hand side both the green lights are absent now, which is indicating that there is no AC and it is not charging, battery is not charging. Orange light means now it is in the backup mode. Now suppose again we switch it on, simulating as if the current is available now. It is now switched back to AC, and we can see on the two green lights on the left hand side are available. The second one indicates that it's charging and it will stay lit, which means the battery is getting charged up. So friends, we are now at the end of this video. Here we will again see that we are using a LIVFAST Sinewave Inverter with a LIVFAST MXTT 1963 battery, which is a 160 ampere hour battery with a 63 months warranty period, which is much greater than other available batteries in the market. So the choice was obvious, and it is also recommended that the inverter, the company that you are using, should be the same as the battery that you are providing. In this case, we have used a LIVFAST inverter, which is a Sinewave inverter FCS1125, and we are using a compatible battery that is also manufactured by the same company, LIVFAST Maximo MXTT 1963 with 160 ampere hour with 63 months warranty. So thank you very much, friends. I hope this will provide you a slightest in view about the inverter and the battery. Thank you very much.